Hello, everybody, and welcome to today's webinar presentation, Developing IoT Edge Applications with MQTT, brought to you by Faircom. I'd like to introduce you to our presenter, Shane Johnson, Head of Marketing at Faircom. Shane Johnson is a former Java developer and architect specializing in distributed systems. Prior to joining Faircom, he led technical marketing for Red Hat, followed by product marketing at Couchbase and MariaDB. And with that, I'll hand it off to Shane.
Thank you and welcome everyone. I appreciate you sharing your time with us today to talk a little bit about MQTT, Edge, and development. It didn't occur to me until just a few moments ago. I don't think I have a proper agenda slide. So before we dive in, I'll give you a little hint at what we're going to cover over the next hour. First and foremost, I'm hoping to cut myself off around 45 minutes. So I would like to save some time for Q&A for everyone. But within that block, we'll spend the majority of it talking about the MQTT protocol. So if you haven't actually been hands-on with MQTT, or maybe you've heard it in passing, you know that it's an IoT protocol, but not much beyond that. That's what I'm here for, right? We hoping that everyone walks away today with a much better core understanding of MQTT. Then we'll pivot and we'll take a look at some of the building blocks of the Eclipse Paho Java library for MQTT with a little bit of code examples on how to connect to a broker and publish messages and subscribe to them. Then we'll finish with just a few thoughts around microservices and how we might be able to take advantage of MQTT and the types of things that we can build and do. And then only at the very end, I'll share a little bit more about what Faircom does in some of our products and how they might help with this. But by and large, this is really a presentation about MQTT with edge development in mind. Let's go ahead and get started. Why MQTT? Right, we already have HTTP, and REST is certainly the dominant, way of exchanging data. Right, whether it's through web services, microservices, even HTML and JavaScript. So why did we need something? It's just because it's a different environment. Of course, REST is powerful when we're talking about the internet. Right, we're really talking about online people who are requesting information, and it is typically a one-to-one interaction, right? I want to see the details of a product. I want to add a product to my shopping cart. And from that perspective, my internet is probably really fast, whether I'm at home or at work, and I can rely on it, right? It's persistent. Yeah, maybe the dog ran by and unplugged a cord or something, but generally speaking, I'm not too concerned about good internet when I'm at home or at work, and even as long as I have a cell signal, right? 5G is fairly good. When we kind of shift into the Internet of Things, it starts look a little bit different, right? We're not talking about people requesting information. We're talking about connected devices, right? Machines and other equipment that are publishing data about themselves, right? Really events. It is my temperature reading or a pressure reading or the speed of a car. And those exchanges are more along the terms of one-to-many, which means I might have many applications that want to monitor, say the inner workings of a factory or the cars within a fleet or the air quality of a building, or even many-to-many, right? Many applications, many different sensors and machines. So it's a different type of interaction. And the internet isn't something we can rely on, right? Especially depending in remote places. I once talked to someone who was working on a farming initiative, and I believe it was Brazil, and they wanted to install these soil sensors, and they wanted to capture that data via satellite because there was no internet where they were, right? There was not even a 3G, 4G, 5G internet. There was no connectivity for them. And you could even say the same thing if you're talking about oil refineries or pipelines, sewage plants, even to a certain degree factories. We can't walk in with an assumption that there's high-speed internet, not only between these edge locations and the cloud, but also not between the individual devices, right, or stations that may be here. So fundamentally different, sets of expectations for machine-to-machine communication, and that's what we're talking about with MQTT, right? It's M to M. We just assume the internet's not very good, right? Let's not bank on having an awesome network. We also assume we don't have a lot of computing resources. These aren't fancy MacBook Airs. They're not even powerful iPhones. We're talking about connected devices that might be really small, right? One core, one tiny little core, just a few K of memory. And we know that we might be making quality of service trade-offs, right? Sometimes it's important. Sometimes it's not as important. I think I was looking at a presentation the other day, and in terms of security, your door, being open or closed is important. Right? Think about that at home, and we have one of those Google Nest locks. So yes, it's not going to be happy if the door is left open. But then there's other things. We also have the Google Nest thermostat. I'm not terribly concerned about every temperature reading throughout the day. If one's missed or one's lost, it doesn't matter to me. It probably doesn't matter to Nest for that matter either. So we'll make those trade-offs as appropriate. And we expect lots of connected devices, much more than your average website, depending on the use case. When you really get into web traffic, you might have, thousands, potentially millions of visitors a day, at the higher end of the spectrum. Generally pretty rare to have a million concurrent visitors, right? Like everyone literally this very second is on my website, but that could be the case when you're talking about IoT. If you're Google and you're thinking about all those Google Nest thermostats, all over the world, or if you're Tesla and you're thinking about all those cars, all over the world, all of a sudden the number of connected devices actually becomes very big. But from a protocol perspective, also very simple and easy. That was kind of an objective going into it, and ideally industry agnostic, right? I use examples all the time. I might say factory, I might say plant. I just talked about, Google Home. So, it really doesn't matter what the industry is. Hopefully this is a kind of a generic protocol that's just easy to use and helps us solve these problems with machine-to-machine communication. Arguably, it's the de facto standard. There are a few others, right? There's CoAP is another alternative for M2M communication. And still, some people might opt for, HTTP or REST. Some people might opt for something custom. But when it comes to open standards, MQTT is certainly at the top. And if you look at some of the details, which are occasionally easy to gloss over, they achieve those goals, right? It is lightweight. I mean, it's literally a fixed 2-byte header, right? It takes 2 bytes to describe what type of message is being sent. The Java client is about 64K, right? And from a protocol perspective, there's only 15 types of messages. And arguably, we could say it's about half that because they're kind of split between the requests and the responses, right? So there's a publish, message type, and then there's a publish acknowledgement message type, right? It's just the mirror, the other side of the coin. It's asynchronous and push based. This can be a big difference if you used other types of message queues in the past, which are pull based, where from a client perspective, you have to kind of loop and continuously pull the broker to see if there's new messages available to you. And when you do, you often get a batch to some degree of those messages. It's bidirectional, right? MQTT clients can both publish and subscribe. And because of that architecture, we say it's loosely coupled, right? So there's an indirection between, say, a dashboard that shows me the state of various equipment in a factory and any particular machine, sensor that's in that factory, right? They are not bound physically to each other. So quite simply, clients publish messages to the broker, and we'll call them publishers here at R. Brokers essentially store those messages and will forward them to clients. So just a minute ago, we said it was push-based. And then those clients, they receive the messages from brokers because they subscribe to it. So a client subscribes to a broker, and from that point forward, when the broker receives a message, he'll automatically forward that message or push it to the client. And then finally, clients can be publishers and or subscribers, right? They could be one or the other or both, depending on what you're trying to accomplish. A few little examples here. Let's just say we have a web app and a mobile app, and both of these are subscribing to a broker. Although interestingly enough, if I were to redo this slide a little bit, that mobile app might not just be one instance, depending on how many people have it installed. Maybe it's hundreds, maybe it's thousands of instances, right? Regardless, they subscribe to that broker, and then say we have a device on the left side, and the device could be anything, right? Look at earlier, I think I said, I have the Google Nest, door lock as well as the thermostat. So maybe the thermostat is a good example of a device. It's going to publish data to that broker, probably the temperature and other things like that. So when it publishes it to the broker, it automatically publishes it to all the mobile apps that are running, as well as any web application that might be running. And it's essentially real time, barring any network issues. But if we go a little bit step farther, it's not quite just one big blob of data. Those messages are organized by topics, and topics that are hierarchical. So I did kind of a little example here. I was thinking fleets. So I might have multiple fleets, and within each of these fleets, I might have multiple vehicles, could be different types of vehicles. And maybe there's different types of sensor data that I can capture from these vehicles, from tire pressure to engine temperature to, say, speed, or even how much fuel is left in the tank. Those would be examples of topics that different clients can subscribe to. So the second part is the wildcards, and those are the last two parts. That plus sign, we just refer to that as a single level wildcard. So fleet 1, car 1, tire 1, pressure. Tire 1 is our third level, right? Level 3. So if I put a plus there, it would say, show me the tire pressure, show me the pressure of all tires on car 1. Maybe it's a 4-wheel car, maybe it's a semi. Maybe if I were a little bit more abstract, it could have been a motorcycle B2. But the point being, it doesn't matter which tire, right? Consider all of them, and then the pressure. Or I could do something like that pound sign, which is a multi-level wildcard, and that essentially says for anything after this. So this means I want all sensor readings for car 1, around the tire, around the engine, the gas tank, maybe even climate control. Give me everything for car 1. So in this way, you can start to see we might have different clients that want different things. We might have, so I was thinking about a rental car, and the last time I did that, that they will charge you an arm and a leg if you don't refill your gas tank. But it could be interesting to have a client that just wants to keep track of how much fuel is left in these cars, which ones need to be refilled, which ones are most likely to need more or to need less, who actually refilled their car 10 minutes before they returned it. That's an interesting use case. Versus you might have another one that is more about the engine temp and the tire pressure and how healthy or what state is our fleet in right now. Does everyone have a good car that's driving well, or are we concerned that someone's using a rental car that, quite frankly, it looks like it might break down soon? Entirely different use case and probably entirely different application and client. Or as an example where we have multiple topics. So we have, we just kind of split it out, and maybe our web dashboard is subscribing to topic A. Well, maybe our mobile application is subscribing to topic B, which is a subset, right? Maybe topic B is alerts or critical events versus topic A is just everything, right? So for my dashboard, I probably have a bunch of graphs and charts, but my mobile application might just be a little bit simpler and give me a very big message if something gets wrong. They'll subscribe to 2 different topics. So if we publish the topic A, that web application would receive it, but not the mobile app, right? This is just general, for our example here, let's just pretend it's general sensor data. It is, maybe the temperature, but for topic B, maybe that's door open close, and that goes to my mobile app to let me know that, someone opened my door, which could be informative to me if there's nobody home and I'm kind of confused as to how and why my door was opened. But I don't necessarily need the temperature reading, all the day throughout the house. That's not relevant to me. Or both, right? I mean, a client can also subscribe to multiple topics. And if a client publishes to multiple topics and another client has subscribed to both of them, they receive both the messages. So the next part of this is a little bit more on some of the features of MQTT. And for reference, I'm talking about basic features, which is really MQTT 3 or 3.1.1 if we want to be a little bit more precise. There is also MQTT 5, right, a newer version, which included a number of more interesting and advanced features. And maybe those we'll save for another day. So maybe we'll do a follow-up webinar for DZone and we'll do a deeper dive into MQTT 5 and kind of show some more examples and use cases around that. But for those of you that are just kind of dipping into this IoT MQTT space, this is our scope. This is our context here. Quality service, persistent sessions, retain messages, and last will. As I mentioned or hinted at a little bit earlier, MQTT does support different quality of service options. 0 is your typical fire and forget, right, at most once. When I think about myself, this is a good example for, I'm sure, my Nest thermostat is sending the temperature up to Google Cloud, continuously. Any one individual reading is probably completely irrelevant. If it was lost, so what? It doesn't really matter. QoS equals 1. This is your at least once, which really means that yes, clients are going to get it, but they might accidentally receive the message more than once, right? There can be duplicates. So this might be a case for some things that are, interesting. I think, it's kind of funny. I'm using this example more than I realized, but it keeps popping up, is that I have Google Home, right, and the whole Google Nest lock. And when I'm at my office and someone approaches my door, I get the whole doorbell noise, not just from the house, but from my Google Home. So it's alerting me, that someone's approached the door and ringing the doorbell. If there were a duplicate there, it wouldn't really bother me. I mean, I would just ignore it. It's not super contentious. And then QoS equals 2, that's your safest option. That is where we ensure that, all clients will receive the message exactly once. So that's kind of your more critical scenarios where duplicates, for example, might be alarming. I said earlier, the whole door open close thing, that might be a little bit bothersome to me if I was getting duplicate messages of my front door being opened and closed, because that catches my attention and makes me have to get up and go check, is the door open or not? So that might be pretty inconveniencing to me. Persistent sessions. If you remember, we made assumptions early on that we can't expect perfect internet or networking. And so the protocol has certain features baked into it to accommodate this fact, and persistent sessions is one of them. So you have clients publishing and receiving messages. If some of those clients are, say, prematurely disconnected, right, the broker will store those messages until they come back. Right? It's not going to discard them, but it'll wait until that client is able to reconnect. And once that client does reconnect, it's going to receive all of the messages it missed while it was offline and get caught up. So this is one aspect where, the protocol is trying to accommodate environments, particularly when we think industrial IoT, where network access might be intermittent, it might be up and down, it might be flaky. This will help us get through that. Retained messages are an interesting one. So each topic can have one retained message, and this is a message that new subscribers receive. So if I installed an app on my phone to monitor something, maybe it's my irrigation system. When I first subscribe, I'll get an initial message. What that message is up to us, right? The people that are building the system. It could be, the last time the sprinklers went off, or it could be, the last critical alert. But no matter how we want to describe it, it's just a single message that new subscribers get, and you can update it. So it's not a one-time thing, right? You might decide that, every time there's a critical flaw, right, when the irrigation system doesn't work, send a retained message so that any new subscribers are aware that something broke, an hour ago or 2 hours ago. Conversely, you might do it for every successful watering. Anyone that subscribes, hey, here's the last time the irrigation system went off and watered the lawn. So it's just, in a sense, you can think of it as like the last good state or the last bad state, right? The last critical event that any new subscriber should be aware of when they join. Last will, a little bit like it describes here, clients can also post a message to a broker and ask the broker to hold on to it in case something goes wrong, right? So if a client is ungracefully disconnected, right, a machine broke or someone turned off my phone and the battery died, that message will be forwarded to the other clients to let them know, right? Here, this client failed. Here was the message they wanted to give to other clients should that happen. It could be, hey, this device has failed. Please, do this or do that or go see this person. But there's not much to say beyond the description, right? Last will and testament, and that's on a client basis. So retained messages is on a topic basis. You have one retained message per topic. The last wills are essentially one per client, right? Each client has its own last will. So hopefully that provides everyone a little bit of an overview of MQTT, why it exists, some of the features it provides. The next step I wanted to do was just walk through the Paho Java client. So MQTT being an open protocol, right, an OASIS standard, there's lots of implementations. I think from an open source and a Java perspective, Eclipse Paho is probably your go-to if you want to get started. In probably any language, really. Eclipse Paho has clients in multiple languages. I'm sure there's Python and C# and C++. So that's probably the first place I would turn to look. I happen to be a Java developer, so that's where I started. And I would say, fairly simplistic to work with, right? Back when I first started talking about MQTT, one of the objectives was to be, very simple to implement and very easy to use. And I think that's mostly the case with the Paho client. So here's 6 classes of relevance. The first one is the MQTT client. That's exactly what it says, right? That's your starting point. That's how you're going to connect to a broker. That's how you're going to send messages and receive messages from that broker. MQTT connect options. This is where you might set things like the last will and testament for our client. We might specify whether or not we want to have a persistent session. We'll use those with the client. MQTT message, MQTT topic. Yes, fantastic. Straightforward. We know that we're talking about a messaging system with messages and topics, and lo and behold, that's what we have. And then the last two are a little bit more interesting. the message listener. So this is an interface with a simple method that you override to basically do something as you're receiving these messages from a broker. MQTT callback has a handful of methods, so a little bit more sophisticated. So I'd say the message listener there is super simple, right? That is as simple as it gets. The MQTT callback interface has a few more methods to implement around message delivery and message received and a few other things here and there. We're not going to show any code today around the callback, but we will show a little wrapper for the message listener. So here's what it looks like in practice getting started. I mean, the only thing you really need to connect to an MQTT broker is, of course, the URL, right, and port, where is it, and a client ID. And this class also happens to have a static method that will help us with the client ID. This method, I believe, generates a client ID based on the system username and the time. You can, of course, create a client ID any way you like. This is just a little helper that's available to you out of the box. MQTT connect options. This is what we might use to do a little bit more granular overrides. Some stuff is fairly straightforward. You see the username and password, right, to authenticate against the broker. That last one you see, that's the last will and testament, right? So on this topic, here's my payload, which is a byte array. We can see the MQTT version. I mentioned this earlier, we're focusing on 3.1.1 right now. That second one, clean session, this is that persistent session I was talking about. So I would put false to say I want a persistent session, right? So if I reconnect, I want to resume where I left off. But I could put true and say, you know what, I just want to resume where things are right now, right? I don't care about the messages I missed while I was offline. And then of course, at the very bottom, you see the client.connect, and then you pass it in these options. Publishing a message is fairly straightforward too. In this case, we just create an instance of that MQTT message. We set the payload, which again is a byte array. The QoS, I happen to put 2 in here as an example, and whether this is a retained message or not. So a few slides back to talk about retained messages. You can publish 1 retained message per topic, and you can override it. So in this case, I might be publishing a message and saying, you know what, this is a critical event, retain this for any new subscribers. I want them to be aware of it. And then there's a couple different ways to go about it, but the one I liked was to get get the topic, so client.get topic, and then from the topic class to go ahead and publish that message. You can publish a message from the client too, but for whatever reason, I find it a little bit more straightforward if I go ahead and get the topic and then use the topic to actually publish those messages. And then subscribing to messages, it's up to you what you want to do in here, but this is the MQTT message listener, right? So it has that message arrived method that we need to override, right? And really you can do whatever you want in here. So we're saying, subscribe to this particular topic. I think QoS, so 2 is the QoS, sorry. 0, 1, or 2 there. And then, an override for what I want to actually happen in here. Fairly straightforward. Like I said, the other approach would have been to kind of implement the MQTT callback interface, create your own class, and then you can do client.setCallback and pass it an instance of that class. Or you can do something simple like this. So that's kind of a brief coverage of the Paho client, which I know it doesn't look like a lot, but that's because it was never intended to be a lot, right? It was supposed to be simple, supposed to be easy, fairly straightforward. What does this have to do with microservices? So that's often what I hear. The first thing we get to is microservices, and that's all how I like to do my demos and examples. So a few things to consider when we talk about edge applications in MQTT. The first is that MQTT is bidirectional. So when you think about it, some of my examples here seem kind of unidirectional, right? We're publishing sensor data, for example, but they can come back the other direction, right? Because you can be a publisher or subscriber. So I might fix my audio. Hopefully my audio transitioned okay for everyone here. But we might take a machine, and on one hand, it could publish its sensor data, which is great, but it can also be a subscriber and receive control messages, for lack of a better word. And again, this is a good example with mobile apps and probably IoT is when I think about Google Home and Google Nest. From my phone, no matter where I am, I can check the temperature, I can check the status of the doors and the locks, or even see what's on the camera. I can also send control messages. Right? I can raise the temperature, I can lock the doors. So MQTT is bidirectional, right? You can not only use it to tap a stream of sensor data, but you could also use it to send commands to control devices on the other side. The other thing I think is really fascinating is that we don't need a database, right? So when we think about MQTT, there's lots of different clients who can subscribe to it. There's no reason you shouldn't have a client somewhere that is subscribing to that feed and probably persisting that data to a database, right? Or some MQTT brokers are also able to persist messages to a database. Point being, it's not your responsibility, right? I mean, you can build a microservice or application for any particular use case, no matter how fine-grained it is. You're going to have the same data as the database does, right? You're just another client who's receiving it. So that I think is an interesting part, because then you can choose to do what you want with the data you're receiving. You could keep it in a list in memory. You could actually use an embedded database. Maybe you want to use an embedded database because you want to begin to do, say aggregation and analytics with SQL. It could be anywhere, but it simplifies with your microservice because you don't have to worry about things like database replication or caching. Whether your caching is in sync or not in sync. All of that goes away. And you're also generally in this edge space not concerned with all historical data, right? I mean, if a factory's been online for 2 years, it's pretty unlikely that you're going to develop an application or microservice that cares about 2 years of data. Most likely you care about current state, maybe at best the past week or month, and that might be pushing it. Unless you're doing AI/ML, in which case you might be more concerned about historical data, but you're probably not going to be working off of MQTT anymore, to be quite frank. So I think of MQTT, IoT, and microservices as our ability to build these types of applications which can either visualize and provide someone the ability to monitor what's happening with these connected devices, whether they're small consumer electronics or very large industrial machines and equipment. To conversely, building also very simple interfaces allow them to control them, right? To remote start your car or change the temperature of your thermostat at home, or to change the setting or speed of a robot arm at a factory. These are all things that we can do with our microservices, and it's really fascinating because MQTT protocol is all we need. We don't actually need a SQL. We don't need a database. We don't need historical data. We don't have to pull, right, or continuously loop or request or check for new data. We're proactively informed of these events and how we want to store them and persist them and
and search them or visualize them, that's completely up to us. So I said I would save this for the end here, and I'm not going to spend too much time here, just a few minutes. Then we'll take any questions that we might have. Faircom Edge, right? Why I'm here talking to you today. This is our solution to the problem. It is an MQTT broker, but it's also much more. So we look at it as really an edge computing foundation, if you will. It's one part MQTT broker, which is everything we just talked about. It's one part database, and it's one part web server. So all of those MQTT messages, when they are published, Faircom Edge will actually parse them, store them in tables, right, as rows and columns, which provides you the ability to access them through SQL, JDBC, ODBC, and then it will convert them to JSON documents and forward them to clients who have subscribed. And it doesn't matter what the input is. One particular example, if you're in an industrial, say, factory setting, you might have Siemens PLCs, they have binary user-defined types. We can attach those binary types to MQTT messages, send them to Faircom Edge, then you can build, say, a dashboard or mobile app, and you actually get those MQTT messages forward to you, but they're now in JSON, right, which you do know how to work with, as opposed to some proprietary binary format in a factory. You can also extend it, build custom dashboards, transform data, things like that. So that's Faircom Edge. The notable significance here is it's an MQTT broker. And I say that because it's very easy to get started with. I'm not sure that there's an MQTT broker out there that is easier to do so. And it is simple as what you see here. So go ahead and download it. You can do it as a zip file, just extract the zip file, run the executable, and then you can open in a browser this URL, and that will actually take you to the MQTT Explorer. So we have a web UI, a web admin UI, if you will, for the MQTT broker. So that's an easy way to start publishing messages and subscribing to them. And you can monitor it. You can see that happen in real time. Then you can go ahead and use something like the Paho client and start playing around and building some clients or even some microservices that are interacting with Faircom Edge, that are either publishing messages to it or they're subscribing to it to receive messages. So Faircom Edge will make the MQTT part really, really simple from a broker perspective. And that Paho, the Eclipse Paho Java client for MQTT, will make it really simple from an application or microservice development perspective. So put those two things together and you should be able to start playing around fairly quickly. But with that said, I think we're about 40 minutes in, and I wanted to save a little bit of time in case anyone had any questions. So I'm going to pause here to say thank you. I know it says Mike, but my name is Shane. So I appreciate your time today, and we'll see what we have.
Yeah, so it looks like we have a couple questions already. The first one is, when QoS equals 1, are there ways for the client to identify the duplicate messages?
There are. So there is a message ID field that can be set. It wasn't in my example. I think I had an example of creating a message, and I didn't set it, but I could have set a message ID. And that's precisely what is recommended, that if you want to use QoS1, but you still want to have some logic to deal with it, just check that flag to see if it's a duplicate. The other thing it does, and we didn't really get into the protocol here too specifically, when a client will publish a message to the broker. Let's say it's QoS1. And what happens is the client is essentially waiting for an acknowledgement that its message has been received and forwarded. If it doesn't receive it in a timely manner, it will resend it again, but before it does, it will also set a duplicate flag. So in the MQTT message header, one of those bytes, I forget exactly which one, but one of those bytes is the duplicate flag. and that will actually be turned on for these duplicate messages. So that's another way that other clients can verify if it's a duplicate or not, is they can actually check that duplicate flag and realize, oh, they were just resending it because we weren't acting fast enough. So hopefully that makes sense. The short answer is yes. There are a handful of different ways to check and see if there are duplicates.
All right, so another question we have is actually a scenario. A client publishes a message to a topic and the subscriber is not able to read it. So it becomes a case of retained message, but the client keeps on publishing to the broker. Will the subscriber get all the messages when it is up?
Yeah, so there's a couple things, and I'm going to separate them a little bit. There's two concepts here. One is persistent sessions. The other is retained messages. I'll start with persistent sessions because that I think is really what you're getting at. Is when a client connects, the client can specify whether they want a persistent session or not. If they want a persistent session, that will be noted by the broker. And should the client go offline, the broker will store any messages that continue to arrive that it would have received, right? That are being published to a topic for which that client had subscribed to. The moment that client reconnects, let's say it's back online or turned back on, it will catch up by receiving all of the messages it missed while it was offline. So it is kind of it's a little bit like a pause and resume thing. I left off at message 10, I was down for an hour, I came back up and I immediately got messages 11 through 50. And the next message will be 51, whatever it might happen. Retained messages are a separate thing. They're not necessarily about that. They are a message that should be given to new subscribers, like new clients. So if I just hired a manager and he's installing some apps on his phone, and one of them is this monitoring app. He's a new client in a sense, and his app, when it connects, it will get a retained message from any topic that he subscribes to. In a sense, that's just like a starter message. It's kind of a welcome message to new clients, if you will. Hopefully that makes sense, but if I garbled that a little bit, please feel free to ask the question again, and I'll certainly try again.
All right, so our next question is, are there differences in performance between the different QoS levels, and are there any limitations?
Yes, that's probably the most notable aspect is the performance. So the QoS 0, fire and forget, is going to be the fastest, right? I mean, your client is essentially publishing a message to the broker and then completely moving on. QoS 1 is a little bit more work. The client will store a message, publish it, and then kind of wait for an acknowledgement from the broker before deleting that message and moving on. So there's a few more pieces there. The QoS 2 is a dual handshake. So there's quite a few extra steps in order to guarantee that exactly once message delivery to all of the subscribers. So hopefully it gives you a little bit of an insight into what's happening with these different QoS levels. But you were right regarding your instincts that the lower quality service levels are really fast, and the stronger ones start to get slower. I wouldn't say they get terribly slower, unusably slower, for example, but they do get a little bit slower because they do more work to ensure that safety.
All right, fantastic answer. Our next question is, are there possible secure connections?
Yes, yeah. So I think that's actually baked into the MQTT protocol. So it is designed for TCP networks, and it supports TLS, SSL connections, as well as authentication. The latest version, MQTT 5, goes one step further and adds, I think, pluggable authentication and maybe even some degree of authorization. So while I didn't touch on it too much here today, there's quite a bit of security baked into it. And certainly all of the MQTT brokers out there, they're implementing those security mechanisms as well.
All right, so we have another question. Can you have multiple brokers to handle redundancy and loss of a broker?
Yes, there's a handful of ways to go about that. It's not part of the protocol though. Excuse me. So high availability is implemented by each MQTT broker in whatever form they choose. Sometimes you'll see replication or clustering. Other times you will see them taking advantage of the fact that MQTT is largely a stateless type of application. But yes, there are ways to have multiple brokers, absolutely. And I think that's with most vendors too. I don't know that there's any outliers who do it or don't do it. I think you'll get HA out of all of them.
All right, someone else is asking, what is the difference between MQTT listener and MQTT callback? And to be specific, when to choose one over the other?
Yeah, there's a few more methods available. So the message listener, it just has that single method for message arrival. I forget the exact name of it now. The message callback has a few more methods. I think one of them is for notification of message delivery, maybe. And I actually forget what the third method was in that class. So I think it just depends on what you're trying to do. If you want more insight into the goings on between a client and a broker, you can probably implement the MQTT callback, or there's another one. I think it's MQTT callback extended, which provides even more methods. So the deeper you want to go and the more insight you want, that's probably how you make your choice. If it were me and I'm just getting started, I would probably just do the listener because it's fairly easy.
All right, someone else is asking if there is a failover broker concept.
There's failover. It's not in the protocol though. So there's, I don't know how far we get into it, but let's say, for example, if you're using multiple brokers and maybe a proxy in front of them, or maybe a virtual IP address, or some clients might allow you to specify the URLs of more than one broker. So that one, there's not really a uniform way to describe it. And I think what you're going to find is each kind of vendor has their own approach or their own recommendation to how to ensure HA, which includes things like failover.
Awesome. And how many max topics and messages can brokers handle? And can we have load balancing concepts at broker level?
The last question, yes, you can certainly do load balancing at the broker level. You could even do really interesting things. I might even argue that there is a benefit to splitting topics, putting different topics on different brokers. So you definitely want to ask yourself, do they all have to be on the same broker? That being said, I'm not aware off the top of my head of any limits on the number of topics. There may be, I'd have to check myself. Arguably, there is no limit on the number of clients though. By design, they're intended to support tens of thousands or even millions of connected clients, whether they be devices or otherwise. So no limitations there. I suspect there's no limitation on topics, or if there is, it's got to be fairly high. And yes, you can absolutely load balance or segment topics across multiple brokers. In fact, I probably would.
All right, our next question is, does MQTT support transactional messaging, say to guarantee delivery of a set message, all or nothing, as well as guarantee the message order?
Yes, I want to say yes on both. I don't really think about message ordering as often when I'm talking about MQTT, but that quality of service equals 2, which is the exactly once semantics, that's essentially a transactional message delivery, right? That will guarantee that your message has been received exactly once by all of the subscribers that are available. So yes, that is transactional. The ordering, I want to say yes, but honestly, I'd have to go back and verify that. I believe so.
All
I think
right,
where it might
and
vary, sorry, I think where it might vary, and we can get into this, if we do a follow-up webinar, There are some new features in MQTT 5. Shared subscriptions come to mind, where instead of sending the same message to all clients, you can actually distribute messages across clients. That one I might be more concerned about ordering because you're distributing them. But that aside, I wouldn't be as concerned.
All right, thank you. And why the restriction to max one retained message?
I don't know. I think that would come down to the designers, right? Those who are working on the protocol. So I don't know if I have a good answer for you on the logic part. But I guess from a retained message standpoint, excuse me, it's really supposed to be, I don't know if this is the right word. On one hand, I'm saying a welcome message, but it is a message that is supplied to a new subscriber, right? The first time a client subscribes to a particular topic, they get this retained message. I'm not sure if it would be worth having more than one because it's really only supposed to be, a one-time thing. It's kind of like, if you check into a hotel and there's like a gift basket, on the first day, you're not going to get one every day, but when you first check in, maybe you'll get a gift from the hotel. In our case, it's supposed to be, like I said, I think good examples might be the last, critical alert. The last time, either something broke, or it could be, the last time, something was replaced, or the last time something successfully completed, a job completion, for example. So I think when we look at those type of examples, maybe it isn't as practical to have multiple retained messages. But just in case there's some confusion, because I know I slipped in and out of these topics, retained messages are completely separate from persistent sessions. So if we're talking about messages the broker stores when a client is down for some reason, that's unlimited, right? As long as there's space, the broker is just going to keep saving those messages while a client is offline. That is not limited to one, right? The retained message is a special case where you want every new subscriber, not a reconnecting one or not a failed one that's recovered, but a new one to receive some seed information as it gets going. Hopefully that helps.
All right, and it appears that was our last question.
Fantastic. Well, thank you for the great questions, everyone, and thank you for your time.
All right, well, with that, DZone would like to thank Shane for a fantastic presentation. And DZone would also like to thank Faircom for providing the audience with a great webinar. And lastly, thank you to everyone who attended today. We hope you learned something new that will help you in your developer career.